Welcome everybody. Here we are again doing a little physics. All right, today is a very nice, easy day. We're gonna introduce circles, and I found circles are just a little bit tricky. So what I'm hoping is we can get started here, and if you see it several times, it'll soak in a little bit easier. So here we go. Let's back up and let's talk a little bit about acceleration. We're gonna do circles and approach it from acceleration today. So if we define velocity, it's going to be the change in the position vector over the time. Now, usually we put a delta t on there on the bottom, but really it's whatever time frame we're using. Most of you are pretty comfortable with just plugging in the time over which we're doing. So to do that, you're going to write down the final position vector, subtracting the initial position vector, and then write in the time. So what we're looking at is just right over here. All right. Let's go down to acceleration. So acceleration is the change in the velocity vectors over the time. Pretty much the same equation. We're just using velocity now. Let's do a quick example. Pretty straightforward, I hope. Go ahead and draw this, and I'm going to be talking, so pause me when you need to. We've got something speeding up here, a car, a person, a cat, whatever. Starting velocity v0 between position 0 and 1. v1 is between positions 1 and 2, etc. on out. As we move down here a little ways, what we're going to see is I wrote down velocity, or sorry, acceleration, and then I wrote the magnitudes of each of these vectors. So remember, the magnitude is the length. So vector v0, notice what I wrote right down over here. Let's make sure you're seeing it. When I do a vector and put two bars around it, so v0, that just means the magnitude. That's the mathematical language for magnitude. So really, my little chart there is actually redundant. I didn't have to write magnitudes above it and put magnitudes down, but I did. So vector v0 is 1 long, 1 something. v1 is 2, and then 4 and 8 for the other two. So let's just pick a point we want to know. So I'm going to say I want to find the acceleration between 1 and 2. All right, so that's going to be the velocity vector number 2 minus the velocity vector number 1 divided by the time. All right, how are we doing so far? So vectors have direction and they have magnitude. So let's do the direction first. Let's write down. Let's copy those vectors down. I'm gonna move them down, and so right down here I'm gonna draw vector v2. That's about the right length. There's v2, and then I'm to subtract, which you guys all have been doing just fantastically at. We take the negative of vector v1 and add it, and that's about right for the length. There's v1. Okay. So delta v, or the change, is going to be from the start to the end, and that's my acceleration vector. So that's the acceleration from 1 to 2. So there's my acceleration vector. And how long is it? Well, it's the length of v2, which is 4, minus the length of v1, which is 2, divided by the time. So if I go over here and I want to find the magnitude of my acceleration vector, okay, it's going to be 4 minus 2 divided by the time. Now I didn't do this one because I didn't tell you what the times were in between. If it was the time between, if it was a second, then from 1 to 2 is 1 second, and from 2 to 3 is 1 second. Okay? So the time from 1 to 3 is 2 seconds, so I would have an acceleration of 1. All right? So I hope we're doing okay with this. Now we're going to do another example, and all I'm going to deal with is the direction of the acceleration. I'm not going to do the math to figure out what the magnitude is, but we're going to get the direction, okay? So brand new example. Here we go. And now, check this out. This is very, very different. My thing is going in a circle. My cat is in a circle, or my car, or whatever. I wrote down the equation for acceleration, and all the magnitudes are exactly the same. The thing is not speeding up. In our last example, things were going faster. But now, whatever we have going in this circle is not speeding up. All it is going in a curve. Now here's the crazy thing. Let's do an acceleration. Okay? Let's take the acceleration from 1 to 2. Okay, so that would be the velocity of 2 minus the velocity of 1 divided by the time. So you first think to yourself, well, golly Wally, it's not speeding up. The acceleration's got to be 0. Well, guess what? We're going in a circle, so things are just a touch different here. Let's copy down our two vectors here, okay, and see what happens. So I'm going to copy them down in green. All right, so V2 is about like that. There's V2. And then I need to subtract V1. So let's add the negative of V1. So here's V1 pointed the other direction. How are we doing? See what I did there? Negative of V1, add it to it. And in red, I'll do the acceleration vector. There's acceleration. This is bizarre. I have an acceleration even though I have no change in the speed. Now the velocity did change because we're changing direction. So let's take this acceleration vector and put it up on our diagram where it belongs. It belongs between V1 and V2. Now look at that. It's pointing in between them towards the center of the circle. And guess what? All my accelerations will point that direction. Okay? Let's back up a second. See if we can understand just a little bit. Another example. If I drop something, the acceleration vector points down. Okay? The acceleration vector is in the same direction that gravity is pushing on it. So the push from gravity pushes it in that direction. Well, let's think about it. If you're walking straight and you start going in a circle, like we did in our problem here, what direction do you get pushed on? You get pushed towards the inside, towards the center of the circle. That's what helps you change direction. So we haven't made this connection yet, but the acceleration is in the direction of the push. All right? And for circles, acceleration is always towards the middle. Okay? If you're walking, if someone's going to push you to walk in a circle, they always have to push you towards the center. Okay? So guess what? That's all. In circles, acceleration goes towards the center. That's what I wanted you to know. All right? Now, you have a couple problems to work on, and we're going to do those in class, and you're going to need the equation, and I'll show you that once you get to those problems in class. Okay? So we're not going to cover that right here. We'll just cover it in class, all right? As far as the actual equation for what that acceleration is. We can figure out the value of it. It takes a little bit of math, and so we'll just do that together in class. Here is your problem, your video lecture problem, and I hope you enjoy. Have a great weekend or evening or wherever you're at.